in the beginning of the course, in the first two introductory lectures, you have seen the idea of a software development process and what the various steps or the stages are going to be to this process. Now, starting today, we are going to delve into each one of these steps in greater detail and take a look at what comprises each one of these stages. The first stage in the process of doing software development is typically that of requirement specification. So, the person who needs the software or the system in order to work with is in the process of writing down exactly what the system is to do for them, so that this can be effectively communicated to the people who are going to build the system for the client. And that is the process of software specification. It is a fairly well refined science, and we are going to take a look at what the different types of software specifications are that exist, what are the different ways of going about writing down a set of precise software specifications, and to take a look at how these things can be organized in a structured manner in some kind of a requirements document. So, the first step in the software development process, like I talked about, is that of what is called requirements engineering. And requirements engineering is really a process in of itself. Requirements engineering deals with the process of translating the ideas that the client of a software system may have in their heads down to being a specification on paper that can be well understood by the consultants, by the contractors, by the software developers who are eventually going to be the ones who are building the system. So, this is a process of establishing the requirements the customer has of a system and the different constraints under which the system is expected to work at the customer or the client side, right? And the eventual artifacts that come out of this engineering process is a requirements document. And the requirements document has within it individual types of requirements. There may be functional, non-functional requirements, as we'll see later during this talk, and the different constraints that the system would have to adhere to when it is functional at the client side. So, let's get into the notion of what exactly is a requirement itself. We are talking of requirement specification, but what is a requirement? Now, the requirement can range from being a high level abstract description of what the system is expected to do or a constraint on the system, all the way to being a very precise mathematically formulated specification itself. Now, the reason why this wide range exists in the definition of what a requirement is because it can serve multiple purposes, right? The requirement itself can be used as a basis for putting out a request for proposals, right, or an RFP as it is commonly called in the software world. When this is done, this is often done with the intent to have the contractor or the software developer put together a bid as to how they are going to go about developing the system for the client. And so, this may be the basis for a bid or a contract, and so it has to be open to a certain amount of interpretation, right? The actual design or the development side of it must not be specified, must certainly be left open in a requirement specification, and even the requirement itself must be left open to a certain amount of interpretation. Now, this may be the basis for the contract itself. Now, when it is the basis for the contract itself and not the basis for the RFP or the proposal, then it has to be defined a lot more rigorously, right? So, there has to be a certain level of detail, there has to be a certain level of specificity that must be attached to the software requirements, and in order that it is now not open to misinterpretation by the other parties, because this often results in one of the things that have to come out of the software specification is what will eventually be delivered to the customer or the client, and the costing methodology that will be used as well is going to figure into this. As a result of which, so we have seen the range of what a software requirement can be. It can be something that is not to use the word vague, but it can be something that is not very precisely specified and open to interpretation, all the way down to something that is very mathematically specified, very rigorous, and something that is understood well enough that there cannot be two opinions about it, and there are different needs for this, and depending on the kind of need that you intend to address, you will end up defining the requirement in a particular manner. So this is, in the words of a famous software engineer called Davis, it's basically that you have to be careful not to over specify at the time that you're putting out an RFP for contractors to prepare bids for, right? The requirements must never overstep their bounds into the realm of design. They pretty much should not be dictating how the system is to perform what it is to do, but it is always to consign itself to specifying what the system is to do itself, right? So both of these documents can be called requirements documents. One of them is fairly open, like we talked about. One of them is pretty closed, very detailed, and there is no room left for interpretation. But both of these things can be called requirements documents, and they're organized based on the client needs at the appropriate point in time in the software development lifecycle. Typically, there are two kinds of requirements that a requirements document will end up containing, and they can be classified along two different axes. One axis is that of the user versus system requirements, right? User requirements are typically those requirements that end user of the system, the manager of the development process, the contractor can understand. So these are the audiences for the user requirements documents. They are typically written in a natural language. They don't include computer jargon of any kind, and this is typically the requirement that the users will sign off on before the development process is to begin. Now, the system requirements, also sometimes called a functional specification, is written more from a developer's perspective by an architect or an analyst who is intending to precisely lay down the rules along which the software system is going to be built, right? So it defines the system's functions, it defines the services of the system, and defines the constraints, the precise constraints along which the system is expected to operate at the client side. And this is typically the basis on which the contract is signed between the client and the software developer, the system requirements. Now, another axis, in fact, along which this can be differentiated, is something called a functional and a non-functional requirement specification, as we shall see shortly during this lecture. Here's an example of a user versus system requirement specification. The first bullet on the slide is actually referring to a requirement that states that the system that is being put together has to provide a means of accessing external files created by other tools. So for example, if you're let's say if you're on a Windows system and there is a file that was downloaded which is a PDF file, or it may be a MPG file, or it may be a GIF file. There are different types of files. Now all this is stating is that the system that is being built, right, let's say the operating system in this case, has to be able to provide a means of accessing and opening and viewing external files that are created by other tools. So at the level of the user, this is what is expected. Now an analyst or an architect would take this user requirement and translate it down into a series of fine-grained steps, if you will, which precisely state what are the different pieces of functionality that have to be included as part of the system, right? For example, in this particular case, the requirement of being able to access external files is boiled down to, first of all, the user needs to have a facility to define a file type, right? So typically if you use a browser, you might want to attach what are called MIME types and associate each MIME type with a type of file that the browser sometimes ends up downloading. So the browser knows that when a PDF file is downloaded, it has to launch a PDF viewer, right? So that definition, the capability of defining that association between a file type and a tool which has to be used to open the file is needs to be available in the system. The second thing is that every external file should have an associated tool which can be applied to view the file, barring which, there has to be an option given to the user to do a selection dynamically. And this is also typically seen when you try to open an application that say the Windows system does not understand. It will typically pop up a dialog box in which it will request you to make an association of an application with the file type that it is unable to understand. So if it cannot be predefined, there has to be a way of dynamically defining this association as well. Now every external file, when it gets downloaded onto the system, needs to have an associated icon that can be attached to that file. So PDF files typically have the Acrobat kind of icon that gets attached to the file. So instantly on looking at the icon, you know that it's a PDF file, can be opened with a Acrobat Reader or any other PDF viewer, right? And finally, the fourth, this high level user requirements definition is being boiled down to 4 steps, and the fourth step is that whenever the user ends up selecting an icon by double clicking on it, then the effect of this double click must be to apply the associated application to the file and open the file for viewing by the user, right? So something as simple as a high level user requirement, which was to be able to view and open external files on the system, files that are created by tools other than what the system provides, has been translated down into something much more precise in this particular case. And that is what really tries to bring out the difference between a user requirements definition, which gets translated down into a more precise specification. So it's not a definition at this point, but it's a specification of exactly the kind of functionality that the system is expected to provide, and also the exceptional conditions that might be encountered, and how the system is going to end up reacting to these kind of exceptional situations. So as we see, there are three different categories of documents that can end up getting created at the very start of the software development process. One is a set of user requirements, and the audience for something like the user requirements, like I mentioned before, are typically the end user, system end users themselves. They are the most important audience, and certainly the managers or the customers who are going to end up buying the system, the managers at the customer site who are going to end up buying the system, because they may not understand the engineering jargon that goes behind building the system. What they're interested in is the end product of the process eventually, and what they're going to get, right? At the same time, the engineers would also be interested, the developers who are going to end up building the system would be interested in looking at this just to get an idea of what the user ends up expecting. The system requirements, however, have a very different kind of audience typically. The system requirements are written not by the user, not for the user, but they are written translating the user requirements into a more precise specification. The translation is done often by system architects or by analysts, business analysts within the software development company, and the audience typically are meant to be the development staff themselves. It's somewhat closer to a design specification, although design specifications typically now get into the area of defining how to build the system and not what the system is expected to do. Another axis along which requirements can be classified or categorized is that of functional and non-functional requirements. Functional requirements, as the name indicates, has something to do with what is expected in terms of functionality of a system's behavior, right? So how should a system react to a particular set of inputs? What exactly should be the series of steps that the system is to perform in order to accomplish a particular task? How should the system behave in particular exceptional conditions? So for example, if a file is not present and it's going to try and open that file. So those are the kinds of, it's a statement of services that the system is expected to provide purely from the perspective of the functionality of the system. Now non-functional requirements obviously includes everything else. It's the catch-all bucket to put in requirements that don't fit into the functional structure of the system. right? And there are several subcategories of non-functional requirements. We'll get to see some of them during this lecture, but roughly this has to do with requirements that don't directly deal with the functionality of the system, but which does end up affecting how the system behaves in the end. So a good example might be that the system is expected to run on a computer which has less than 128 megabytes of RAM. That would be a non-functional requirement, something that is not externally visible from the system's UI or the behavior, but it is something that could have an impact on the performance of the system, which is not directly maybe perceived by the user, may or may not be perceived by the user. A slow system is certainly something the user is going to notice, but this is not something that is functionally part of the system's interface. It's something that is a constraint on the way the system is going to end up behaving. It can also be a constraint, for example, on the development process itself, the kind of tools, the kind of technologies that are going to end up getting employed. So for example, a non-functional requirement could state that you have to conform to CMM, SEI CMM level 4 in terms of your quality processes during development. It has nothing to do with what the system is going to end up doing, but it has something to do with the processes that you end up following as a development organization itself and some of the standards that you may end up using in the process. So this is something that we've already gone through. This slide essentially describes the notion of what functional requirements are, and they're essentially high level statements of what the system is expected to do. So we're going to move on here, and here is an example of functional requirements or user requirements actually for a library system that provides a single interface to a large number of databases which can contain articles from different libraries. And the users can essentially either search for different articles, and they can search for it based on different parameters, authors, the title of the article, the area on which, or the topic on which the article is written, and so on. They can download these articles and print them for personal use. Now, if we take a look at such a system, and that was kind of the user description of the system, so to speak, the functional requirements, when you try to translate this down to what are the functional requirements of the system, it could boil down to one of 3 points. The first point being the user should be able to search for all the articles from any one of these databases, or select a subset of the articles based on certain search criteria that they are going to specify. And some of the search criteria may be the author's name, the first or the last name of the author, or it can be the year of publication, it can be the title or certain keywords that may be present in the article, it can be a topic on which the article is written, say computational biology. And if they search for articles in computational biology, then the system should be able to display every article that falls into this range. The system should also provide for appropriate viewers for the user to read the documents in the store. The documents can come in several formats, remember. In a library, documents can be in PDF, it can be in Microsoft Word, it can be in PostScript, or it can be in various other formats, and the system should be able to provide viewers for the formats in which it stores the documents in. And every order for downloading the document, because there is a certain cost that is to be borne on the system side for this, is going to have an order number that is unique and is to be associated with it, that can be used for tracking for the purposes of cost, for the completion of order, and so on and so forth. Right? So those are some of the functional requirements, examples of functional requirements that can be given for the library system that we are talking about here. Now, when you take a look at some of this, right, there is a certain degree of imprecision that you may have noticed in writing down requirements. And certainly problems are going to arise when the requirements are imprecisely stated, right? Since it is open, it is ambiguous, it is open for interpretation, what the client may think of may not be what the developer is thinking of from his perspective when he looks at the requirements. So one of the things that you can consider in the previous slide was that it has to contain, the system has to contain all the appropriate viewers for the users to be able to view the documents. Now the user intention was that there would be a special purpose viewer for each document type, right? The Acrobat PDF viewer for PDF files, Microsoft Word, etc., for Word files, and so on. So that association would be made by the system, and the appropriate viewer would be fired upon the document being selected. The developer interpretation could be something totally different in this case, and he may consider the fact that I can extract the content of the document into plain text, represent it in a textual viewer, and display this to the user. Now both of these would satisfy the term appropriate viewer as was specified in the requirements document, but the ambiguity and imprecision with which it was laid out can create significant problems later, as is pretty obvious from this example. So in principle, requirements have two important characteristics that they have to satisfy. The first characteristic is that of completeness, right? So the requirements have to be complete in the sense of specifying exactly what the system is to do, and it should also specify along the same lines what the system is not to do, right? So that is the definition of completeness. And the second characteristic that is very important when writing down requirements is the notion of consistency, to avoid the kinds of ambiguities and the openness which can be interpreted in different ways that we saw in the earlier example. There has to be a certain degree of consistency. There should not be any conflicts or contradictions in the descriptions of the system facilities, right? A good example might be one in which the system is being asked to perform a certain requirement out of a minimum number of say chips that was used to build the system. So this is not a software system that's being built, it's a hardware system, and this notion of requirements could equally apply to a hardware system specification as well. So the requirement on this particular system specification was that it would be built with a minimum number of chips because of the problem with size, and so multiple functions had to be put on the same chip. But on the other hand, another requirement in the same document stated that due to power considerations, right, each chip had to use the least amount of power. Now there is a certain element of contradiction about these two requirements. One is stating that you need to use the smallest number of chips, which would mean that combining multiple chips functionality onto a single one, which means the need for power is going to go up. At the same time, it is also stating that due to power constraints, you need to be able to have chips which consume the least amount of power. So in practice, these kinds of conflicts are going to arise all the time, and it is considered close to impossible to provide a completely consistent requirements document, although there have been the development of formal methods which allow you to verify through machine verification techniques whether the requirements are complete and consistent. But that's something that we're going to look at in one of the later lectures in this course. So so far we've looked at the notion of what user and system requirements mean, and we've seen another axis along which categorization of requirements can be done, called functional and non-functional requirements, and we have seen the definition of what functional requirements are and what is the purpose that they are to serve. We'll now take a look at what non-functional requirements mean. As stated before, and as the very name implies, non-functional requirements have to do with system functionality that don't exactly concern the user experience directly, right? So these define systems properties and constraints. It could be on processes, it can be on development methodologies that you end up using, it can be on technologies that are employed to build the system, it can be on performance, reliability, availability of the system, and so on and so forth. So they themselves can be categorized into various sub classifications. And so some of the examples that we've seen earlier are a particular process that has to be adhered to during the development of the software system. So for example, the CMM SEI level 4 process, or it can be the use of a particular technology. So for example, a web page that has to be built should not contain frames. is a kind of a requirement, or it can be a performance requirement or an availability requirement about the system, which doesn't directly affect the user experience of the system. And one of the things that is not to be confused is the fact that non-functional requirements doesn't mean that they're not as important as the functional requirements. In fact, there can be many situations in which non-functional requirements are often much more critical, right? An availability requirement, for example, if the availability requirement on a system, say for trading systems that are used by stock exchanges and so on, must be close to 99.99%, right? If you even had the loss of the system availability to be say 5% and bring it down to 95, this could translate into a loss of hundreds of crores of rupees, typically for systems which have very high trading volumes, right? So some of these non-functional requirements, as they're termed, can in fact be much more critical than functional requirements, and if these are not met, the system can also become quite useless in nature. So some of the classifications that we can take a look at as far as non-functional requirements are concerned are product requirements. So product requirements can be things like execution speed. Let's say you were doing transactions on an e-commerce website. So this was a e-commerce site that you were building. The e-commerce site had users coming to it to buy certain goods. In this case, one of the non-functional product requirements could be that 85% or 90% of all the transactions that are conducted on this site shall complete under less than 5 seconds, right? So execution speed can be one of the product non-functional requirements. Reliability, like I mentioned earlier, or availability of the system is another product related non-functional requirement. Now another category that we can look at is what are called organizational requirements. So organizational in the sense that there are certain policies and procedures that can be followed in a particular organization, and those policies and procedures have to be taken into account during the development of the software. So process standards that are used, so let's say it's an ISO 9001 compliant process that was used to produce the product. That's one of them. And then there can be what are called external requirements, which are requirements that arise from factors that are completely external to the system and the process that was actually used to produce the system itself. So one of the examples could be that this application, software application that is being built has to work under any J2EE compliant web server. What this is trying to state is that if I change out a piece of infrastructure from underneath this application today and replace it with another infrastructure that is kind of equivalent in functionality based on a certain standard, then the application should be able to perform in exactly the same way as has been stated in the requirements document. So there can also be legislative requirements that the system has to work, especially applications that are developed for the military, for example, come under very strict laws or legislations which say that this has to conform to certain standards, guidelines, it has to conform to certain quality guidelines and so on and so forth that are kind of external to the system, the development process in itself. So this slide actually gives a more detailed kind of breakup of the different non-functional requirements we can have. Still starting at a high level are the product non-functional requirements, the organizational non-functional requirements, and the external non-functional requirements. And the product requirement itself can be classified as usability, it can be classified into efficiency requirements, into reliability or portability requirements. Efficiency, under the heading of efficiency would come something like performance, for example. And performance need not always be in the execution speed aspect of it. It can also be in how many resources are consumed by the system in order to provide the functionality. So for example, if the system has to fit on a disk which has less than 10 gigabyte of disk space, or it has to run on a system that has less than 128 megabytes of memory, those are space requirements, right? And performance requirements, on the other hand, really have to do with how fast the system executes and so on. Now, organizational requirements can be classified further into delivery requirements, in the sense how is the system packaged. Is it going to be in a CD, is it going to be downloadable software, is it going to come on a tape of some kind, etc. There can be licensing requirements attached to it, implementation requirements, this particular standards process has to be used during the implementation, and so on. And external requirements are classified typically into interoperability requirements, that you have to be able to interoperate with these other external vendors. So for example, if I am buying a system from Oracle to do my financial accounting, then we can put in a constraint saying that I have an SAP ERP system and I have to be able to put data into this as well as extract data out of the SAP system and be able to interoperate with this particular system. Then there can be legislative requirements, with the advent and the explosion of web-based systems, privacy concerns have taken a very important role, and so there can be privacy requirement. For example, the data that is provided to the system shall not be shared or shall not be accessible by any other person. So there can be security requirements, safety requirements, and so on and so forth. Those are external to the system and the development process by which the system is made by itself. So some of the examples of non-functional requirements, once again, is product requirements with respect to the library system that we were talking about earlier, is that the user interface of the system should be implemented in straightforward HTML, and there can be no frames or Java applets to be in this, because this could arise from the fact that the system can be accessed from really simple client boxes which may not have the hardware capability of running heavy duty Java programs. As a result of which there is a requirement that says there can only be a browser on that side, there may not be the capability to run Java, as a result of which the user interface must be plain HTML. So that's a product requirement, and it is also not directly concerning the functionality of the system. So it's a product non-functional requirement. So the organizational requirement, like I talked about, can be process related. The standards that have to be followed during the development, say the ISO 9001 standard, so on, so the SCI CMM standards, and so on and so forth. The external requirement, on the other hand, is one of the privacy things that we talked about before. So the system shall not disclose any information that is given to it, especially regarding users or any of the details of the users, and only internally to the different modules of the system shall this information be accessible, but by no other non-user of the system can this information be extracted, is one of the conditions. This may of course in turn translate into a specification that says that any and all user data that is captured from the system shall be encrypted and stored with 128-bit encryption, or and so on, which will guarantee the security of the data. So one of the important things that we have to watch out for is to distinguish between the notion of a goal and a requirement, right? Goals are typically an intention of the user, right? So one of the goals of the system may be to bring down the time to process a particular document. Let's say this is an insurance processing, claims processing system that we're building, and it's taking extraordinarily long today to process each insurance claim. Let's say it's taking like 40 minutes to an hour per user, and one of the goals may be to bring down this time. Now this can get translated into a requirement that says there has to be some usability factor that is built into it. So for example, the user may have to be able to learn the system with less than 2 days of training, and after this the user has to be able to process insurance claims in 30 minutes or less, right? So this is a verifiable non-functional requirement that is being introduced into the system with the goal of trying to improve the general productivity of the organization for which the system is being built. Now it is useful to have both goals and functional requirements and non-functional requirements part of the requirements document, because the goals convey a sense of what the user intends to do with the system, and this is always going to be useful to the software developer, the designer, in putting together the system itself. So here is an example of the differentiation between a goal and a verifiable non-functional requirement. So the goal is that the system should be easy to use by experienced controllers and it should be organized in such a way that user errors get minimized. And how do you turn this into a verifiable non-functional requirement is that it says that the people, experience controllers who have a good idea of the domain should be able to catch up to the system functionality with less than 2 days of training or 2 hours of training in this particular example. And after this training, average number of errors that are performed by these human operators using the system should not exceed 2 per day. Right. So, this is a very quantified requirement, it is very precise, and it's a non-functional precise requirement, and that kind of takes the broad goal that has been laid out of building a usable and a human friendly system and lays it down into more precise language of being a verifiable requirement. So, we will now start taking a look at some of the techniques that can actually be used to put down these requirements. Right. So, if we take a look at user requirements, they should describe both functional and non-functional requirements in such a way that they are understood by the system users themselves. So, it should be expressed in some kind of natural language. They can use diagrams, they can use tables, etc., but it has to be understood by users without the detailed technical knowledge of how the system is going to work, but exactly what the system is going to do. Right. The problems, as soon as we think of natural language, let us say that the requirements are going to be written in English. The first problem that comes up is that there is a certain degree of ambiguity or the lack of clarity around natural language. Right. Precision is very difficult to achieve when something is being written in English, which is why English is not a computable language directly. Right. So, there is this lack of clarity, and to achieve a certain degree of precision is going to be very difficult without making the document be far too verbose to read. So, the requirements document can run into hundreds of pages because every small functional requirement is being specified to a great degree of detail. The other issue that can arise is requirements confusion. So, the level of detail could get mixed up. So, for example, at one level it can be conceptual, but the same requirement can also be talking of a different level of detail which is very fine grained. Right. So, that is one aspect of it. Functional and non-functional requirements can tend to get mixed up. That is another aspect of it. So, the requirements confusion kind of tends to cover this notion of mixing up different levels of detail, mixing up different types of specifications or different types of requirements into a single statement. Finally, there is the notion of what is called requirements amalgamation, which is a situation that tends to combine multiple requirements into a single statement or is being expressed together. Right. So, for example, there can be the notion of trying to introduce security as well as some kind of costing practice into the same system, and we will see some examples of this as we go along, but these are some of the problems that arise with natural languages. Right. Here is going back to the example of the library system that we were developing earlier. Here is an example of a requirement that causes some degree of confusion. Right. So, this statement, and I am going to read it out verbatim just for your reference, is libsys shall provide a financial accounting system that maintains records of all payments made by users of the system. The system managers may configure the system so that regular users can receive discounted rates. Now, what is the problem with the statement as you would see it? Right. The first thing is that there are two requirements that are being stated in this one specification. The first requirement is that conceptually they want the library system to now have the notion of some kind of a financial accounting package that is attached to it. So, it's a very conceptual notion at this point, very high level. It is not detailed or specified, specific enough to say what exactly that accounting package is going to do. But at the same time, the next sentence, which talks about the notion of configurability by the system's managers and users receiving discounted rates, is very specific, right? And so, these two requirements, which are being merged into one single specification, have very widely differing rates of specificity about them. One is quite general, quite conceptual, and the other one is quite specific and very precise. So, the mixing up of these two kinds of specifications, which results in what is called requirements confusion, is certainly something to be avoided. It also looks at both functional and non-functional requirements getting mixed up together in this particular case. So there can be several ambiguities that result from a specification such as this. Here is another example which we won't go into a great level of detail, which is also mixing various kinds of requirements. So, so the first example of the ellipsis system that we saw, it like I discussed earlier, already mixes the notion of a conceptual requirement and the notion of a more detailed requirement, and it also includes some unnecessary detail at this level. Now, the fact that there needs to be a financial accounting system and the fact that system managers should be able to configure that particular system in a particular way is something that can be separated out clearly. And the next example about the grid also mixes various kinds of requirements which are conceptual, non-functional, UIs, back-end requirements and so on, which is certainly to be avoided. One of the things that will help in this particular case is to do a structured presentation of the requirement. So, start breaking it up. So, we can say that in the grid editor example that we laid out, one requirement can be about the grid facilities, where the grid itself should be laid out as a matrix of horizontal and vertical lines. It should always be a background to the editor window, right. That is a very specific requirement, and the grid shall be a passive grid where the alignment of the entities is the user's responsibility, right. That is one particular requirement. There can be some rationale to back up this requirement as is shown on this particular slide, and the specification is very clear. It says this particular tool shall be used to build this, and this is the person who wrote out this specific requirement 2.6.1 about grid facilities. So, a structured presentation of the same requirement, instead of simply writing it down in as a plain English paragraph and breaking it up into a certain set of sections. The first section could be the actual stating the requirement. The second section is a rationale for why, and this provides the intent or the goal of the user, which can be taken into account by the designer of the system down the road. And then if there are any other constraints that are to be met as far as this requirement is concerned, this can be specific technologies that are going to be used to meet the requirement, certain processes that are to be followed to design this requirement in, and so on. And then the source of the requirement must always be included. Reason being that if there is any ambiguity about it, then the source can be contacted and the appropriate clarifications can be sought. So, the guidelines then for writing a set of requirements that can be easily processed, that can be clearly understood by both parties, the party that is seeking the software system to be built and the party that is actually building the system, is to invent, first of all, to invent some kind of a structured standard format and to use it across all requirements that you end up writing, right. And so, along with the structured standard format, there may be certain terminology that may be defined. All the terminology is going to be defined upfront, and the same standard terminology and the language is being used in a very consistent way through the rest of the document, right. The third thing is to use text highlighting. It's a very common feature that is used to point out important parts of documents and important parts of text, and it identifies key requirements very clearly. One of the things that we should always stick to is to avoid computer jargon in the specification of requirements as far as possible, right. There can be situations where this cannot be avoided. For example, the use of frames versus the use of plain HTML in the UI. This to a certain extent does assume knowledge of technology from the user's perspective, and it is a non-functional requirement, but to avoid situations which would expect the user to understand certain computer technology in any way or at any level is to be avoided as far as possible in the requirement specification. The moment the requirements gets translated into a specification instead of a definition, these things are going to start creeping in, and that's okay at that point in time, right. So, system requirements are they're more detailed specifications. They are specifications as opposed to requirement definitions, as we saw earlier, and they are intended to be used as a basis for designing the system down the road. A high level architecture is going to be performed upon analyzing and reading these system specifications, and these are typically used for incorporating into a contract that is signed between the client and the customer in this particular case. right? In principle, requirements need to stay away from design, right? The requirements are meant to state what the system is to do and not how the system is to accomplish the task. In practice, sometimes it is difficult and this distinction does get blurred, and they become inseparable in certain situations. So the system architecture, for example, may be designed to structure the requirements itself. The system may interoperate with other systems that generate design requirements, and that can also be a situation in which the line blurs. And the use of a specific design may itself be a requirement. The classic example was the notion of frames versus plain HTML, right? So far we have primarily looked at natural language specification of requirements. Now we'll try to take a look at some of the alternatives that may exist in using natural language or an English-like language in order to specify requirements. There are three primary categories of alternatives that we can take a look at. One is structuring the same natural language requirement that we've been talking about, but give a very small degree of flexibility to the requirement specifications person by using forms or templates. The forms are kind of pre-canned, and they give a certain degree of flexibility where required, but mostly it allows you to specify things like modules, and on a per module basis it allows you to specify inputs, the outputs, what the module is expected to do, and so on. It does presuppose a certain modularization, but that is something that cannot be avoided with this type of specification. The second alternative is mainly that of what are called design description languages, and graphical notations are often used in these languages. So they are not textual languages, but they are languages which have a certain degree of graphical notation. UML with use cases and message sequence charts is the example that comes to mind the quickest, and this is the most popular one. Even though UML has been used as a design language, it can certainly be used to lay out a certain set of requirements as well. And the third set, which is a category that we are going to be getting into a little more deeply during the next lecture, is our mathematical specifications. And an example of mathematical specifications are algebraic specifications, and here the emphasis obviously is on formality, is on rigor, is on trying to put together specifications that can be proven, as well as systems can be directly generated from these sets of requirements. So structured language specifications, as we've already gone through in a little bit of detail, is the freedom of the requirements writer now gets cut down a little bit because of the predefined template that is now being used for him to specify the requirements, right? And the template also serves one more purpose. It tries to introduce a structured method or a standard by which every single requirement is specified, so that one requirement is not specified in a way that is distinct and different from another requirement. The terminology can also be limited. For example, these forms can be automated and they may not take in certain types of terms. And the biggest advantage really is that it's a nice blend between the expressive power of the natural language and the freedom, the flexibility that it's going to give you, coupled with the rigor that is introduced by the structured form or the template that can be used to write down the specification here. So the form-based specifications, like I said earlier, do lends itself to a certain degree of modularization. So you can assume that there are a set of modules in the system. For each one we are specifying what the module is going to be doing, not how it's going to do it, but what it's going to be doing. And this is typically done using a set of inputs to the module, a set of outputs that the module is expected to generate, and if it is dependent on any other module in the system, for example, any set of preconditions of the inputs which need to be validated by the module. For example, if we were giving a name, then it really cannot be having numerical characters in that, would be an example of a precondition which will validate a piece of input coming in. And the side effects, if any, of each one of these modules or functions within the module themselves are typically how forms are put together. Tabular specifications really supplement the form-based specifications, and tabular specifications are especially useful when a number of conditions would have to be specified and based on the condition and the value of the input variables, any number of output actions may be taken, an alternative course of action may be taken. An example that we will see on the slide is that this is for a meter, an insulin meter that is reading the sugar level, and the UI for this, if the sugar level is falling, then there is a certain action to be taken, and the R2 and the R1 here refer to the previous two readings of the sugar level in this particular case, and the current reading really is R0 in this. So it depending on what the previous three readings were, it is going to take any number of different actions, either change the dosage of insulin that is going to be released, or it may just keep it the same or keep it constant. So this is an example of a tabular specification. Graphical models, like we discussed, are primarily UML derivatives, and these are essentially use cases which are supplemented with the help of method sequence charts. The use cases essentially details use case for every single scenario that is possible with the user of the system. So for example, if you are modeling an ATM machine from which one could extract money or do financial transactions with the bank, then one of the use cases may be that the card is validated upon insertion, right? So what exactly happens within this process is a sequence of actions go on, and the sequence of actions can then be depicted by the means of a diagram that we are going to see down on this sheet. The diagram basically outlines four different actors in this particular case. There is the ATM card reader, the ATM machine itself, which is like an abstract notion of what the ATM is going to be doing. Then for every time the card gets inserted, a session is started by the ATM, which is what is indicated here, and then finally there is the customer console or the user console. So what this diagram is trying to indicate is the fact that first of all the card gets inserted, and once the card gets inserted, then a message is sent to the ATM from the reader saying a card has just been inserted. The ATM immediately then creates a new session that is indicated by the next arrow, and then activates that particular session. This is denoted by the act method that is being called on the session. Now, as soon as the session is activated, it goes ahead and reads the card, which is the first action that is done. So this is the y-axis going downwards is time, if you will, and in the increasing order of time, these sequence of actions are being taken by the different actors in the system. So it reads the card, then it asks the customer console to insert a pin. The customer inserts a pin, which is indicated by the dashed line coming back from reading the pin, and then it validates the card. So this is an example of a graphical notation that can be used to very formally, almost formally specify exactly how specifications can be put together. The last type of specification is really mathematical specifications, and mathematical specifications are those that define requirements with a fair amount of rigor, almost in the form of axioms, if you will, which can be proved using theorems. Therefore, these lend themselves to program generation in the back end. So that's the next lecture, and we're going to get into that in a little while. But just to close out on this, the requirements document is something that is an official statement of what is required of the system that is being built. Right? It should include a definition of both the user requirements as well as of the specification as is going to be seen by the rest of the users of the system that goes behind the scenes. It is certainly not something that will dictate how the system is going to be built. It has to stick to primarily describing what is going to be built. So there are several different users of this document, and it starts all the way from the customer who ends up actually writing this document and then reads it as a reference in terms of what has been specified and what is to be expected of the system that is going to come out, all the way down to the test engineers within the software development organization who are going to read it to build the appropriate test plans and test the system itself. So there is a standard by which the requirements document can be specified. It's called the IEEE requirement standard, and it defines a structure. It defines this template or the structure that we were talking about in a few minutes ago, which gives various sections, and importance is given to both general requirements as well as different kinds of requirements, such as functional and non-functional requirements that have to be incorporated into this document. So going forward, we are going to take a look at how requirements can be specified, as well as formal methods can be used, or mathematical methods can be used in order to specify, validate, and then turn the requirements in the code go into the system.